So let's do another dot product example problem. Yes. So one thing that could be asked, more of a math question, but in the spirit of practicing the dot product, someone could give you two vectors, say these, and they could ask you a strange question like, find the projection of A onto B. Or the same question worded differently would say, find the component of A along B, or in the B direction. Okay, so what does that mean? Well, let's draw it. Now keep in mind, this is three-dimensional. It's pretty hard to draw that, but any two vectors next to each other could be viewed from the side so that they looked something like this, if you can imagine that. So let's say this is A and this is B. Let's say the other way around, actually. God, it does not matter, I'm just being weird. Say this is B and this is A, some kind of vectors. And so I'm trying to find the component of A along B, or whatever. And so what that means is I'm breaking A into components, like we do in the XY direction. But in this case, I want the component of A that's in the B direction, that little dotted line right there, such that this is a right angle. So that is what I'm looking for. Now, the title may have given it away, but the dot product is very useful in this case. But first, let's work it, like we would in an XY problem, where, say we have that angle, and we know that this is the magnitude of the vector A right here, right? So it's A in length. So we could find AB if we knew the magnitude of A and we knew the angle. We would have that, well, we know that the cosine of that angle is equal to, let's see, AB over A. And rewritten, we have that AB is equal to A cosine of theta. Now, we don't have theta, but we can find it using the dot product like we've done previously. We know that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. All right, and so rather than solving for theta, we could solve for cosine theta, or even A cosine theta, because we know that what we're looking for, AB, is equal to A cosine theta. So if I simply divide both sides by B, here, I get that A cosine theta is equal to A dot B over the magnitude of B. And A cosine theta is what I'm looking for, which is the projection of A onto B, or the component of A along B. So now we need to perform the dot product. So let's just keep going here. AB is equal to, now remember the dot product is this, the x components multiplied, plus the y components multiplied, plus the z components multiplied. And we're dividing by the magnitude of B, which is this. And that'll give us our answer. We know all of those components up here at the top. And I don't want to plug them in. But that is an example as to how you can find a projection of one vector onto another, or the component of one vector in the direction of another vector.